Good morning, students. I am recording my third lesson in Malaysia, and I'm at my third different house. So it's kind of funny how I keep traveling around and recording algebra videos everywhere I go. Today, I'm in the home of a little girl who's getting her bath. She's 7 months old, and you can hear her right now. She's a little sad, but she will provide a little entertainment while we talk about Lesson 88. And Lesson 88, you guys, is a lesson designed to make you feel smart. It looks super complicated. When you look at the problems, you'll go, it's scary. But the algebra behind them, you are all ready to do, and it's no big deal at all. So there are two parts to it. The first one is something we call the distance formula. Again, this is a topic, or a calculation rather. A second, I'm a little off today. I have to scoot my paper. The distance formula you will see in advanced algebra courses. You'll see it on the SAT. You'll see it in the AccuPlacer when you get ready for Running Start. It's not a difficult calculation, but again, it makes you look so smart to be able to apply it. And the other one is a chemistry and physics calculation that follows this form. And again, it looks really hard, but just you wait and see. You're going to love it. Okay, let's talk about the distance formula first. When we're graphing 2 points on a grid, it is always possible to label them as x1, y1, and x2, y2. Notice that it doesn't matter which one I call x, the ones or the twos, just know that they exist. And very often we have calculated the distances between them. We've drawn this triangle, right, at different times, and we've used triangles with our trig functions to calculate the distance between the 2 points. What we're going to do today is we're going to teach you a formula. It's a shortcut formula that will allow you to take any 2 points and to calculate the distance between them without having to do a lot of sine, cosine type work in the middle of that calculation. So there's a simple formula. It's called the distance formula. I'm going to copy it right here. It's in your book on page 365. So I'll write that down up here. The distance formula looks like this. It's kind of complicated, but it's easy to use. The whole thing is inside a square root box. So the distance formula is taking the square root of, I like it in this form. Just a second, let me change it. I like to have it in this form. There are several different forms of it, and they all work just fine. You take the second x point, and you subtract the first x point, and you square it. And then you add the second y point minus the first y point, again squared. I like to use it in this form because this is the form we used for the slope formula in our last lesson, so it's very simple to memorize it that way. You just watch it. Okay, that's fine. You're more than welcome to do that. So I like to use this form, as you'll see in the book. Sometimes they write it the other way around. Sometimes you'll see it in different formats, but this is the distance formula. Boom, it'll always work for you. All right? Commit this one to memory and get ready to use it. Example 88.1. Sorry for the shadow of my hand. I try to move it so that you can see. Use the distance formula to find the distance between, and it gives us 2 points, 4 minus 2 and minus 5 and 3. My eyes are getting stronger. I don't use my magnifying glass anymore, but I still have a hard time seeing, so be patient if I make mistakes. All right, so there are our 2 points. We can imagine them as being on a grid. We could graph them if we wanted, but that's not a necessary step of this process. But if you ever feel confused and you want to create a visual, you can draw yourself a little grid and graph those 2 points. But what I'm going to do is I'm simply going to label them x1, y1, x2, y2, and then I'm going to plug them into our distance formula. There, I'll scooch it so you can see the whole thing. All right? Very straightforward. So I like to go ahead and label them so I don't get mixed up with how I'm using them. So I always just write that underneath. And again, it doesn't matter. I can make this the ones and that the twos. NBD, you guys, no big deal. Okay, square root of, here we go. X2 is minus 5 minus, I don't know why I put that little mark there. I'll scribble it out. Minus 5 minus X1 is 4. See, this is why I just label them because it gets so confusing. X2 is minus 5 minus X1 is 4. And I square that plus Y2, which is 3, minus Y1, which is minus 2. Make sense? Okay, so far so good. Just a second, I'm just looking at my notes here. Okay, now I simplify. I'm going to start by doing, oh, there's a square on that one. Now I'm going to start by simplifying. I'm going to work on what's in the parentheses. I'm going to do it in 2 steps. Minus 5 minus 4 is minus 9 squared plus 3 plus 2. That's 5 squared. Yeah? So far so good. Next step is to do the squaring. Minus 9 squared is 81. 5 squared is 25. There you go. I hope you can still see. The sunshine outside is making a strong shadow when I leave my hand there. And then this becomes square root of 106. And John allows us to leave this as the final form. Now, I would be a nitpicker, and I would say that this, well, maybe it can't be. I would look at whether that can be prime factored. But in any case, John leaves this as the final answer. Distance is the square root of 106. So you can see, you guys, these aren't hard. You know how to solve this kind of algebra. It's just a question of applying this formula to the 2 pairs of points that's new. And it's easy, isn't it? But it makes you look super smart because look how hard that calculation looks. So that is part A, the distance formula. Part B, which I'm going to check off the box right now because we're tackling it, and I'm going to flip my page. Part B is similar in that it's a complicated thing that looks really, really, really hard, but it's super easy and you have all the skills to apply it. This relationship PV equals nRT is a formula that you will see in chemistry and I believe physics as well. It's definitely in chemistry. And once again, like we've been doing with all of these applications, we're not going to talk about the science of it. We're just going to pretend that we understand it. And we're going to focus only on the mathematical calculation. Then, when you run into these in science courses, you will learn about the science aspect of it, and then you'll go, oh, the math is totally easy. So, if you look on page 366 in your books, at least it's 366 on mine, you will see a chart that explains what each of these variables means. And I'm not going to copy it all down completely, but you'll see it looks just like this. And you'll notice these are the same 5 variables that are in our base equation. P stands for pressure. V stands for volume. Whoops, V-O-L-U-M-E. N stands for the number of moles in a gas, whatever. Let's not even talk about that. R is a constant, meaning that you'll always use the same number in this type of problem, and it gives you this in the book, 0.0821. Let me make sure I copied that right. Yes, it looks good. So this, you'll want to refer back and use that number. There, you can see it all now. And T stands for the temperature. Now, in the book, it tells you the unit that each of these things will be measured in. P will be measured in atmospheres. V will be measured in liters. N will be the number of moles, you'll always know that. And T will be always the temperature in kelvins. Those units you'll use to match the numbers to the proper variable. So you refer to that chart on 366. when you're doing these problems, I don't want to make you copy it all down in your notes. That's just a waste of your time. So example 88.2 looks like this. Use the relationship PV equals nRT to find the number of moles in an amount of gas, and then it gives you all the information. So the first thing that you do is you notice, what are we solving for? What is the missing piece in this 5-part equation? And it tells us, find the number of moles. So we know that in this case we're solving for n, because n is the number of moles, okay? So once we know what we're solving for, the first step, the first one, whoops, that was supposed to be a 1, I'll make it a star, is to rearrange, rearrange the formula for the desired variable. So we're looking for n in this problem, so we start by taking PV equals nRT, and we solve for the missing piece. So we want n by himself, so we're just going to divide both sides by RT. Simple, abstract rearrangement that we've done a billion times. So now we know, okay, so this cancels out, and I'm just going to write it in the other order. N equals PV over RT, okay? So now, second step, I'll star it since I didn't number it, is plug in the data for the other variables. All right, so in this example, let me scooch back over here. We're going to want the pressure. So now I'm referring back to my book, and it says that the pressure is 1 atmosphere. So there's the pressure. The volume is our next one. So I look back at my notes. The volume is 8 liters. So I put in an 8. R is our constant. All right, so I copy. They give it to us in the problem, but we'll remember it's always the same. So it's 0.0821. And then the temperature is the fourth piece. And the temperature, I'm looking back at the problem, it's 273 kelvins. Beautiful, yeah? So now it's just a simple measure, a simple calculation, and I'm going to be gracious to you, as is John. You may use your calculator in order to do this. Again, remember the things we've learned about checking your number for accuracy to make sure that your result on the calculator, you know, sometimes if you just get crazy and press a wrong button, you'll go nuts. So run it through 2 or 3 times and make sure that it makes sense. What you'll get when you solve this problem is that n equals 0.357. Okay? So that's the way this style of problem works. Sorry, my pen is skipping. I think I need a new one. So what I want you to do is now work example 88.3 with anyone that you're studying with. Try it by yourself. Follow in the book. Remember, the steps are first to rearrange the formula and then plug in the data. You will feel so smart, and you are smart, but this kind of problem is not going to challenge you too much in any new ways. So, yay for you for learning so much this year and being able to apply it so wonderfully. All right, you guys, good luck with that one. Bye.